Hi, I'm Mr. V, and this is Algebra 1B, and we're talking about exponents. We're doing a lot of practices today. I encourage you to try to do these on your own before watching the solutions, which I'm going to give you here on this video. It's best if you try to do this on your own. If you have no clue, I'm going to show you some techniques that you could use to solve this. And I'm just going to go through the exercises that are in this particular unit. And if I'm going too fast, you can slow it down and watch it at your own speed. But I'm going to follow the same type of ideas that I would expect you to do on a test. So here we go. On this first question, you were asked to do this with a calculator. And then we're going to try to do it with the exponent rules. The very first thing I would have you do when you have exponents like this is to separate the numbers, to put the like terms together. So I have, let's just start with the 3. I have 3 to the 5 on the top, a 3 to the squared on the top. On the bottom, I have a 3 to the cubed and a 3 to the 4th power. I also have 2 to the 3 times 2 to the squared, and then I have 2 to the 5th on the bottom. And I'm going to apply the property of a product of exponents and a quotient of exponents. When you have a product, you can add the exponents. When you're dividing, you subtract. So this is the same as 2 to the 3 plus 2 minus 5. They all have the same base. These all have the same base. This is 3 to the 5 plus 2 minus 3 minus 4. And you get 2 to the 0 times 3 to the 0. Any power raised to the 0 is 1, except for 0, which you cannot raise because that's undefined. So my answer is 1. Our second problem, if a and b or c are positive integers, such that a to the b power is x, I can substitute this in here, and c to the b power is y, I can substitute this in here. When I substitute this in, I get a to the b times c to the b. Uh-oh. That's not one of my answers. But I do know which rule is it? Let me find my table here so I can show you which rule it is. This rule. If I have the power of a product, is what it's called. When I'm raising each one of these to the power, I can make the product and make it go to this power, to this as well. So I'm going to go back to this page. And this is the same as a times c raised to the b power. That's not this one. This is a to the 1, c to the, this is not, you've got to have the parentheses here. They're not being both raised. Okay, we have several problems here. You should look and try to figure out which properties to use. This was in parentheses, and so the first thing I would do is get rid of the parentheses, and I will do that with a white marker. Here, let's see, a white. This guy. I'm just going to white it out because it's all multiplication, and I'm not raising it to a power. Like down here, you're raising the parentheses to a power. So I can just get rid of the parentheses. And now, what is the first thing we do? We're going to put the like terms together. So I'm going to do 3 times 6. I'm going to get rid of any exponents that I see like this first. Then I'm going to combine the powers. So here I can combine the powers. X to the 5. This is times x to the 1. If it's not got a power, put a 1 there. Y squared times y to the 7th. So I get negative 18. X to the 5 plus 1 is just 6 times y to the 2 plus 7, which is 9. Like terms go together. 2 over 8. X3, X7, y to the 8th, y to the 3rd. These are quotients. We subtract the denominator from the numerator, the number of the exponent from the denominator from the exponent of the numerator. So I'm left with 1 over 4 times x to the 3 minus 7 times y to the 8 minus 3, which is 1 over 4, x to the negative 4, y to the 5th. We don't like negative exponents. So we'll use the negative exponent rule. We'll flip it and make this a positive exponent. So we have 1 over 4 times 1 over x to the 4th times y to the 5th. This one, before I start combining like terms or putting the numbers together, I need to get rid of this exponent. This is a power of a product. I've got a product in here, I've got a power, and to do this, so watch me do this, and then I'm going to get rid of the power of a power. We have is equal to negative 3x and y. Every piece in here goes to this power. So I have times 2 to the 4th times x to the minus 6 to the 4th times y squared to the 4th. Now I've got these powers of a power. So before I combine all the like terms, I'm going to get rid of those. How do you do that? You multiply the exponents. So we have 2 to the 4th. It's 2 times 2 times 2 times 2. That's 16. I'm just going to multiply that out. So here we have x to the negative 4, negative 6 times 4, which is negative 24. Y to the 2 times 4, which is 8. And now we can put the like terms together. Negative 3 times 16 times x to the minus 24 times x to the 1. This is 1. Times y to the 8th times y to the 1. And this is negative 48. Here we have x to the minus 23. When you add negative 24 plus 1, to make it a positive, I'm going to put it 1 over x to the 23. Did you follow that? And then we have y to the 9th. Our next problem. The only thing I have here is a negative exponent. I don't have any other things to combine. To change that to a positive exponent, I will flip it and take the reciprocal and make that a positive. And 1 over y to the 5th. Here, we have the same base each time, so I'll add the ones on the top, and I'll subtract the one on the bottom. It's this rule and this rule. What is the value of this thing? Before I start combining like terms, I need to get rid of this exponent. This is a product raised to a power. So I can rewrite this as 4 times the 3 goes to the squared, x squared. On the bottom we have 2 squared and x squared. This cancels. 2 squared is 4, and 4 cancels. So I'm left with 3 squared, which is 9. Here we have two different things going on. I need to fill in this blank with something and this one with something. I'll just put a 1 here. So I have x to the 1 plus 2 is equal to x to the negative 5 plus some blank. But what do I have to add here to make this equal to 3? This has to be 8. You could have started with 2 or something else. These are not the same numbers here. These are different ones. This one, oh my goodness. Let's look inside the parentheses before we just get rid of them. Let's try to simplify this. This would be x to the 4 plus 5 minus 6 is equal to x to some number plus 10. Well, this becomes x cubed, and that's 3 times 3 is 9. When you have the exponent to an exponent, that's 9. It's equal to x to some power plus 10. Well, what is that power? That's going to be negative 1. This was kind of a fun problem, wasn't it? I thought it was fun. Okay, now I can combine the like terms. Let's see. 3 times 5 times x cubed times x to the 1 times y squared. So this is 15. We have x to the 3 plus 1, which is 4, y squared. Oh, this looks so terrible, but it's not. This should be a lowercase c. Sorry, I typed it wrong. Put my numbers together, 12 over 3 times x to the 6th over x squared times y to the minus 4 over y to the minus 6 times z to the squared times z to the third power. Now, this is all the quotient rule, most of it. One of them is going to be a negative exponent, I think. So we have 12 divided by 3 is 4. X to the 6 minus 2 is 4. Y to the negative 4 minus a negative 6. That's y squared. Negative times negative is positive. And this would be z to the 2 minus 3, which is z to the minus 1. So I need to get rid of the exponent, the negative exponent. This should be 4. I don't know why my 4 doesn't come in. So I get 4x to the 4th y squared times 1 over z to the 1 if you want to write it that way. Anything to the 0 power is 1 except for 0, which cannot be raised. It's undefined. To simplify this one, we're going to use the negative exponent rule. Don't tell me I'd have no clue. You should be knowing these exponents and you need to be doing the practice with these to get it. So let's flip it, and then it becomes a positive. Here we have the product, and we're raising it to a power. So each individual part is raised to that power. And we get negative 3 times negative 3 is 9. Times negative 3 times negative 3, which is 9, is 81. Then we get to do this one, we're going to do the power of a power. So we raise this, so this would be r times 4 times 4 is 16. Just a few more to do here. Which expression is equal to this? First thing, let's get rid of this power of a power. That's going to be q to the 4 times negative 3, which is negative 12. And since I'm dividing by this, I can subtract the exponent, which is q to the 3rd. Oh dear, this is different. I've got an x in both of these terms. I've got a 7 can go into both of these terms. So I could write 7 times negative 4x plus 5. And that's not one of my answers. I have to have a positive 4x. So if I make this a negative, this would be a positive and a negative. I could have negative 7x, and then that times 4 would give, x would give me this, times a negative 5. Is that one of my answers? I think it is. It had nothing to do with exponents, but it's just rehearsal of the things we've been doing. Now, to do this, we do the 2 times 3 times x to the 4th times x to the 5th times y to the 1 times y to the 8th. You add the exponents. 6 times x to the 9th times y to the 9th. 6x to the 9th, y to the 9th. And our last one, let's see, for all a's that are greater than 1, what is this equal to? 3 divided by 3 is 0. When you have the exponents, you subtract. So I have a to the 4 minus 2, minus 6, which is a to the minus 2. To make it a positive, I'll write 1 over a squared. Is that one of my answers? 1 over a squared. And that's all of our review for today. Good luck and success.